So I created another game, and this game may look familiar to you because it was one of the most popular games created by Atari back in the day. It's called Breakout. And I couldn't really think of a cool scenario to make this game feel cooler, so I'm just going to go over one of the concepts used to complete this game. And that concept is when the ball hits the paddle. And when the ball hits the paddle, it actually doesn't look, it's not as simple as it may look. Actually, when the ball hits the paddle, depending on where the ball hits the paddle, it goes into a certain direction. So say the ball hits the left or the right side of the paddle, it goes to the right. And when the ball hits the left side of the paddle, it goes to the left. And when the ball hits right in the middle of the paddle, it goes straight up and down. So depending on where the ball hits the paddle, it goes into a different direction. So how do we calculate this? Well, let's say that we have a paddle right here, and this is our bricks up there, and we have our ball. So the ball is going to hit somewhere on this paddle, and depending on where it is on the paddle, the ball is going to bounce back out in a certain angle or certain direction. Okay, so let's say that the ball hits right in the middle of the paddle. If the ball hits right in the middle of the paddle, it's going to go straight up. So let's say this is going to be a 0 angle. So there's 0 angle over here, it's just going to go straight up. And on the other hand, let's say the ball hits right on the right edge of that paddle. It's going to go straight to the right. Let's call that 90 degrees. So 90 degrees from the middle, like that. Okay. Let's say that the ball hits right here, right in the middle, between those two. Then the ball is going to go somewhere at like 45 degrees from the middle. And then for more examples, let's say it hits right here. That's going to be around 30 degrees, and right here, let's say around 70 degrees, something like that. So what's the first thing we need to do to calculate this? Well, the very first thing we need to do is when the ball hits the paddle, we need to find the X position of the ball. So see the ball hits the paddle somewhere around here. Okay. So we find the X position of this ball. We find the X position of the middle of the paddle here, and we get the difference. Okay, so let's call that D. So we get the distance between here and here. Now we have to get the width of half of this paddle. So we get this, and then after that, we can use that to get the percentage of where this ball is in comparison to half of this paddle. So we can do that by going the distance divided by the width of half of the paddle. And let's just write it like this. So we have our percentage. So let's say that this is 0.7 or 70% of this paddle. Now we have to get our angle, we just have to multiply our percentage by 90. And that kind of divides this whole entire thing up into 90 little pieces. So let's say 70% of 90 is going to be, I can't do the mental math on top of my head, but let's say that's 80% or 80 degrees. And let's say that it was right on the edge. So that's 100% of the paddle. And that's going to be 1 times 90. So that's going to be 90. So we just have to get our percentage and multiply that by 90 to get our angle. So now we have our angle. So let me draw this out. So now we have an angle. So this is our angle. This is a right triangle here. And we have our velocity. That's when the ball comes in. That's our velocity. So we know our velocity, and we're trying to find our X and our Y to set our ball. So the ball is going to be the new X and Y. And we have our angle. Let's call it theta. And if you remember grade 11 math, there's something in trig called SOHCAHTOA. SOHCAHTOA. And we only need SOHCAH, so let's just keep it at that. So to find our X, this is the opposite, this is opposite, and this is the hypotenuse. So if you remember correctly, this is sine theta is equal to opposite, which is X, over hypotenuse, which is V. So X is just going to be equal to sine theta multiplied by our velocity. And then our Y is going to be similar, but it's going to be adjacent, so this is going to be cosine of theta multiplied by velocity. And that's how you find your X and Y. And you plug that into your ball, and that is the new angle. So how does this look in our code? So it's basically the same thing. We find the middle of the paddle X, and then after that we get the ball position. So we get the distance, which is just the difference between the ball X and the middle of the paddle X. We get the percentage from the middle. Then we get our angle percentage, or we get our angle. And then after that, our new X is going to be our sine theta. This is just a theta multiplied by velocity. Our Y is cos theta multiplied by velocity. And then we plug that in, we reverse the Y velocity, and we get our game. That is the ball collision method.